All right, so we have a linear first order differential equation on the board here. We have dy over dx plus 3 over x times y equals x squared plus 3. And the first thing I want to do is I want to just check that this is in the correct format that we want. So the format we want for a linear first order is going to be something like this. And that works because notice this is a function of x, this is a function of x. Got our y there, everything is good. And so we're good to go there. So the first step we want to do is we want to set this up so the left side is the product rule. But what we're going to have to do is we want a product rule such that it is in the form uy, like where u is um, what's it, integrating factor? I forget the right term, but use the factor that we want to multiply it by. So it's sort of that's the whole trick to these problems is we're multiplying through by something that's going to turn it into the product rule. It's not going to be the product rule when we get it initially. So then if we just look at the product rule of this real quick, it's going to be this plus this. So that means, let me just multiply through the problem by u, and we're going to have u, here, we're going to have u dy dx plus u times 3 over x times y equals x squared plus 3 times u. So our first step is to find out what is u going to be. And we notice that now this form matches this form, well, on the left side. And so we're saying then, if we're going to match it up totally, see, we have our u and dy matching, but we want this piece matches with this piece. So we're saying this piece has to be u prime. Now, of course, if you're doing a lot of these, you're not going to go through this process every time, but it's just kind of good to like walk through it in your brain so that you're used to understanding what's happening, that this whole thing's the product rule, and that u prime is going to equal u3x. And what you can do is do it as turn it into a separable differential equation, which I'll cover in another video. So this is going to be, for our u prime is going to be du over dx times u3x. And what we can do then is just divide here by u on both sides. Here, I'll just do it rather than it's going to cloud it up. So we're going to have du over u, and then on the other side, we're going to have 3 over x dx. Now I can integrate on both sides. We'll end up with ln of u equals 3 ln x. And then notice just by exponent rules, I can bring that 3 over here and make this a ln x cubed. Let me bring it down though. So we'll have ln x cubed, ln u, and then again with our rules, remember this is base e, so we can say u equals e to the ln x cubed, but you can look at it, this just is gonna cancel, and so we have our u is going to be just an x cubed. Okay, good. So then what we can do now is, well, we don't really have to rewrite this. We know it's going to fold up into this form here. So let's use this, and we'll say uy prime is going to be x cubed times y prime, and then on the right side of the equation, what do we have on the right side? I forget already. Oh yeah, x squared plus 3. So we have x squared plus 3 times x cubed. We can just multiply this out. So we're going to have x to the 5th plus 3x cubed. And we'll just bring this down. And now what we can do, we can just integrate on both sides. So we'll end up with x Integrating this derivative is just going to remove the derivative. So we're going to have x cubed, that's not going to, x cubed times y equals, and we'll just integrate power rule on the right side, x to the sixth over 6 plus 3/4 x to the fourth plus c. Then next we can just divide by x cubed to get rid of this, cancel here. And then what we're left with is going to be y equals x to the third over 6 plus 3/4 x plus c x minus 3. Again, don't forget that you need to divide this x by the c. This is kind of a common mistake to just leave this as a c, because when you're integrating, you're usually just thinking plus c, and you're not thinking about what happens when you divide through. So it still needs to have this x minus 3 here. That's going to be the whole solution right there. So we just integrated and we found a solution for a linear first order differential equation. I'll stop it there.